So again, let's settle back down. Quadratic functions and equations. Okay? We're going to graph and solve these quadratic equations and talk about some other special features about quadratics that you guys may have heard of last year or in previous years. Okay? So, a quadratic. The graph of a quadratic, we all know, is a parabola, yes? It's like a U. The axis of symmetry, raise your hand if you've never heard axis of symmetry before. Even better. Alright, so the axis of symmetry is a line that divides the parabola into two halves. And what's special about the axis of symmetry is that it intersects the parabola at the vertex, which means whatever you figure out for the axis of symmetry is actually the x-coordinate of your vertex. Okay? And then, of course, to find the y-coordinate, you just plug in 0. The y-intercept is what you get when you plug in 0 for x. Okay, that's how you find the y-intercept. You plug in 0 for x. And as you see, it will always be whatever c is. In the standard form for a quadratic, for those that don't remember, standard form for a quadratic is ax squared plus bx plus c. And to find your equation for the axis of symmetry is the equation x equals negative b over 2a. Okay? Some of this, hoping, is review. Yes? Yes. Okay. Good stuff, good stuff. So, let's use the axis of symmetry, the y-intercept, and the vertex to graph that function that you guys see here. Now, the axis of symmetry is always an equation. It's always x equals some number, okay? So do not forget that. It is an equation. If you feel like you're the type to forget like little small things, write that down, circle it, make it bold, okay?
What's the equation?
Like x equals, like it always has that before it. It's never just the number, it's always x equals. So, the axis of symmetry is negative b over 2a. So x equals negative b. What's b in this problem? 2. The 2. And a is what? 1. I have a few more participating, but that's okay. For those that are stuck, remember it's ax squared plus bx plus c. Okay? So a is that coefficient, b is that coefficient, and c is that constant term. So my axis of symmetry is x equals what number? Negative 1. And it is x equals. Please make sure you're putting that x equals. I would hate for you guys to lose the points because you didn't put x equals. So I have some imaginary line that's cutting this parabola in half. Now the y-intercept. You get the y-intercept by plugging in
Why is 2?
0 for x. Question.
You have a line that's positive 1. Why is it not?
Thank you. I'll fix that. So I'm going to plug in 0 for what again?
X.
And find out that my y-intercept is negative 3. So my y-intercept is always written as a point. So it's going to be 0, negative. And again, you get that by plugging in 0 for x. That's how you find the y-intercept. Just for kicks and giggles. How do you find the x-intercept? You didn't ask for it, but how do you find it? Caleb? Set the equation equal to 0 and then do what?
Solve.
Solve. I know it doesn't ask for this, but just kind of like as a looping thing. Let's solve this, okay? Can you guys find my x-intercepts, please? Don't shout them out once you get up and just find them, okay? What do you guys get?
Negative 3 and 1.
Wait, as like your solutions, or as what you got when you factored in? So you got negative 3 and 1. Okay? When you factor, what were the two numbers that multiply to give you negative 3, add to give you 2? Say it again. plus 3 and minus 1. So then you would set both of your factors equal 0, and yes, those are your x-intercepts. I'm looking for my vertex. I know what the x-coordinate is already. It's the axis of symmetry. So my vertex is -1 for the x. To find my y, all I need to do is, what do you think? Say again.
Plug in -1
Plug in -1 where?
for x.
Into what?
The original.
To the original function. So I plug it in. And you don't understand how important parentheses are sometimes? Because you gotta make sure that when you square a negative, what happens? It turns into a positive. So this is +1. Then what? -2, -3. So what is that? -4. Now if you're wondering why I said that, well, it's because some of you guys forgot the negative on a certain part of your test, and it altered your final answer. So my vertex is at -1/4. -1, -4. Yes.
So, we know the x-intercepts, right?
Yes.
Why are we only collecting the -1 from
Because the x-coordinate here, or the axis of symmetry, tells us the x-coordinate of our vertex. So we plug just that in to our original function to find the vertex. Another way you can find your vertex is you can take, or to find your axis of symmetry, you can take your x-intercepts and find the average between the two. Think about it. What is -3 plus 1? And if you divide that by 2, what do you get?
Why would you divide
-1. Because
Oh,
the x-intercepts are halfway from your axis of symmetry.
okay, so it's like finding the mean.
Exactly. So I have -3, +1. I have a vertex at -1/4. And I have my y-intercept at 0, -3. And there we have our parabola. Definitely, okay. Questions on graphing quadratics. Questions on finding the information. The y-coordinate of the vertex is the maximum or minimum of a function, okay? So whatever the y-coordinate is, it basically, helps to tell you if you got a maximum or a minimum. Another way you can figure out if it has a maximum or minimum is looking at that leading coefficient, looking at that a. If a is greater than 0, then we know it opens up and it has a minimum. And if it's less than 0, it opens down and it has a maximum.
By A, it means the y coordinate, right? Okay.
So, like in standard form, we know that this is standard form here.
Yeah.
So say if a was 1, and it, like the last example was x squared plus 2x minus 3. A is 1. 1 is greater than 0. So we knew that the graph would have opened up, which it did, didn't it? When we graphed it, didn't it open up? Last example.
So,
This is the last example I'm using.
okay, yeah.
And it did open up, didn't it? Which means that this would be a minimum. And then the y coordinate of the vertex is the minimum.
Does it, with it a being greater than 0, a being less than 0, is there a differential with relative and absolute? Oh, yeah, it'll always be absolute, right?
It will always be absolute because it's quadratic.
Yeah.
Exactly. And true, it will always be absolute because we are dealing with quadratic here. Right, Caleb? Mm-hmm. The domain of quadratics. We talked about this when we did your foldables. It's all real numbers. How do you represent that in interval notation? Give it to me. Seth, how do you represent all real numbers in interval notation? You said infinity to infinity? One tiny change. There we go. Negative infinity to infinity.
And then set.
And in set, it would be
X such that x is equal to all the numbers.
element.
Okay.
Now the range will be all real numbers less than or equal to the maximum, if you have a maximum, or all real numbers greater than or equal to the minimum. It really depends on where your vertex is and if it opens up or down. Okay?
So what all be real numbers?
So if you have a maximum, it's everything that's less than or equal to that maximum. Or if it's a minimum, it's everything greater than or equal to that minimum.
It'll either go up until or until and up.
Exactly.
Okay. I already know everything.
No, I don't. So here we go. Determine if you have a max or a min. How do you know? How do you know? Because A is less than 0. A is a -3, which is less than 0, so that means we have a max.
So it's upside down?
So it's upside down. And then we have to find that maximum value. How do you find that maximum value? Jasmine? Find the vertex, get the y coordinate, okay? Can you guys do that, please? Find the vertex and tell me, don't shout it out, but tell me what that y coordinate is. So, what you get for the minimum value? What was it? Don't be shy, not all at once.
220.
225? 223.
Yeah.
It's the max.
Did I say min? I meant max. I'm so sorry. What's the max? 223. That's a vertex. Okay. Alright, so to find your x coordinate of your vertex, what did you do?
Axis of symmetry.
Which is
Negative
-b, which is 12 over 2, and a is a -3. So I would have gotten what?
2. Positive.
Positive 2. So then you plug that in. And then what you do?
Plugs it in.
Yeah, plug it in. Solve it. Now I got a question. Did you multiply this and then square, or did you?
You square it and you
Yeah, you use paradox, like every education.
Okay, because I wonder.
Yes.
Because I wonder. You guys said 223.
2,23.
I was like 223. That's why I kept saying it over and over again because I thought you guys were saying 223 as the maximum value. Oh, okay. 2,23. Yeah, okay, let's do that next time. Yes, 2,23. So your maximum value is just 23. Like, I don't even know how to it is. I'm so relatable. I see it on my face, right? I was like, what? So you got what? How do you do this? You guys have seen this before. Solving quadratics, there are 3 ways. Factoring quadratic formula and completing the square. Factoring, we should be good, right? Yeah? Okay? Quadratic formula, do you remember it?
Negative b plus minus square
Wait, what's under the square root? B squared minus 4ac. Okay?
Props to whoever was singing.
So there's the quadratic formula. Sorry. So if you did not remember this, you will need to know this, so please make sure you write it down if you don't know. And lastly, complete the square. Raise your hand if you remember how to complete the square. Okay, so can I start with completing the square first and then?
Yeah.
Okay, so here we go.
I forgot there was doesn't not apply.
Okay, you can solve it on my square. It just pretty challenging. So here we go. Completing the square. This is the last 2. Okay, we're jumping right down to those, and then we'll go back to factoring quadratic formula. So to complete the square, you first need to always make sure that A is 1 and your C is on the other side of the equal sign. Okay? So A is 1, How do I get c to the other side? Subtract 1. Now comes the completing the square process. What you do is you take half of b and then square it. So what's b in this problem? Negative 4, because there was a negative, divided by 2. What's negative 4 divided by 2? Then I square it to get what? 4. And so that number is what you add to both sides of the equal sign. That's the completing the square part, because technically there's a square there. So, the right side, what's negative 1 plus 4? 3. And on the left side, you want to factor this. This actually is a perfect square trinomial. That's what you create when you complete the square. How does x squared minus 4x plus 4 factor down? X minus 2 times x minus 2, which can be written as so then from here, you solve for x.
Why is it x plus 2x
That's a difference of perfect squares. That's what you would get if it was x squared minus 4. But this is the x squared minus 4x.
Oh, so this is a factor of
Yeah. So, how do I solve for x? What do I do? Take the square root. And you have to remember, when you take the square root of both sides, you get what? Plus or minus that number. Can I simplify the square root of 3? No. So you leave it as it is. And then the last step is to? So my answer is x plus or 2 plus or minus the square root of 3. That is the same answer we would get if we use quadratic formula to solve this as well. One quick trick to help you. You always have to factor the left side, and it might not always be nice numbers, okay? So the trick is to get the factored form. Whatever you got when you took half of b is always that number, every time, okay? So if you ever end up with like some fractions as the number that completes the square, you'll always know what the factor form will be by whatever you got when you took half of b, okay? I want you guys to try the last one that's on your paper. What's the first thing? Sorry, both of these should have been x's.
You have to divide everything by 3, right?
Change that to an x first, and then and you divide every single thing by 3. Okay? Leave them in fractions. Do this without your calculator. You can do this. Okay? So you have x squared minus 4x equals negative 4 over 3. I'm going to let you guys finish this off. I know you can do this. No calculators? So you take half of b and you squared it to get 4. So you added it to both sides, yes? Yes. Okay. Then you factored the left to get what? X minus 2 squared, same thing as before. But on the right side, it's 8 over 3. Did anybody not get 8 over 3? Okay.
I kept it as a, I didn't see
Why?
it
Because in order to add a fraction and a whole number, you gotta get a common denominator or do that funky cross thing that I saw some of you guys do. I don't quite understand that, but you know, basically negative 4/3 plus 12/3. 12/3 is the same thing as 4. And you just add the numerators. So the next thing, why do we take the square root of both sides? I didn't talk about this before, but why do we take the square root of both sides? Because you have to isolate the x and the way to do that is to get rid of the square. So when you take the square root of both sides, you will get what here? Plus or minus 8 over 3. Now, I saw a lot of you guys leave the square root of 8 over 3 like that. Square root of 8 over 3 is the same thing as saying the square root of 8 over the square root of 3. Did you guys know that? Okay. Can you have a radical in the denominator?
No.
How do you get it out of the denominator? Okay. By doing what?
We multiply it, well, in this case, we multiply by the square root of 3 over square root of 3.
Very good. You rationalize it. And in this case, we're multiplying by the denominator, square root of 3. To get the square root of,
11.
multiply,
Just kidding.
24 over 3. Does everybody see that? Square root of 3 times square root of 3 is square root of 9, which is 3. Can I simplify the square root of 24? To be so the square root of 8 over 3 is actually 2 root 6 over 3. You want to make sure that you
Plus or
simplify.
minus.
And of course you got the plus or minus. Alright. So this is what we have after we simplify that radical. And then we add 2. So 2 plus or minus 2 root 6. There you go. Questions on completing the square. Do you guys have the steps? You need to make sure that A is 1 and C is
On the other side.
on the other side of the equal sign. Then you
Take B, half it, then square it.
take B, half it, and square it.
Also put on the other side.
And when I put on the other side, I am going to
Add them.
add it to the other side. And then I factor the left, simplify the right, and solve. Cool? Alright, I want you guys to do those 4 problems with factoring quadratic formula. I'll give you guys about 5 minutes and then we'll check to see if we got the right answers.
5 minutes per problem. That's 1 minute.
Alright, did you guys get this for the first 2? 6 and 2 and then negative 1 and 2/3? Yes, and not every one can be factored, okay? So factoring can only be used some of the time, but completing the square and quadratic formula can be used all the time. Did you guys get this?
I didn't.
Make sure you simplify. Make sure you simplify. For this one, you gotta make sure. Well, I like to put all mine on the same side. Makes it a little bit easier. Negative b plus or minus the square root of b squared minus 4 times a, which is 12, times c, which is 96. Positive 96 over 6. You guys agree? Go down. And negative 4 plus or minus, carry the 1, 1 and 12. Yes? Help me out. Let's say 2 goes into that, which makes 56. No, I'm pushing it. Does that simplify? To what?
Equals to 16.
16 times 7? So 4 root 7 over 6. That simplifies to negative 2 plus or minus 2 root 7 over 3. Because all of those are divisible by 2. Okay? I know I'm pushing it. Homework, 12 problems. You guys think you can handle it?
So,